Right, let's have a look at some CSV files. As you can see, I've got 5 of them here, which are inside one of the folders that's zipped up in the zip archive that I've uploaded for Keats onto the Keats website this week. We're going to have a look at them to see what's inside them and what they're for and what some of the problems are, which we will be avoiding by using a particular R package, which is part of the tidyverse. So let's start off with the first one, but let's notice something about them. They're all identified as CSV files by the fact that they have the extension .csv. And my computer's operating system recognizes CSV files as files that are typically opened by Excel, which is why they all have the Excel logo next to them. So if I double click on one now, it's going to open with Excel, and we'll see what it looks like. Okay, there we are. It's opened it as a spreadsheet. Now, a CSV file is for storing what's called rectangular data, which means that we've got a number of columns and then we have a number of rows, and every row has the same number of values in it so that you can line them all up to make a nice rectangular shape like this in a spreadsheet. Okay, so that's what Excel does when we open it, but let's see what's actually inside the file. And to find out what's actually inside a file, what we need is a text editor. A text editor is a program such as Notepad on Windows, or TextEdit on Mac OS, which is what I'm using, or Emacs if you're old-fashioned, or in fact RStudio has a text editor built in. These are programs that they won't do anything to the content of the file that you open. They won't interpret it in any way, they will just display it to you. So we can see what's actually inside the CSV file if we open it with TextEdit, a text editor. Right, okay, so this doesn't look rectangular anymore. This is the data that Excel interpreted to make that nice rectangular spreadsheet. The first row here, we've got column A, column B, column C, the column headings. Every subsequent row, we've got the numbers that were inside those columns. So these are the values, 0, 3, 1, 6, etc. And they are separated by commas. There we go. So that's why these are called comma-separated value files. The values are separated by commas. Okay. So let's have a look at one that's a tiny bit more complicated. And I'm going to open this one directly in TextEdit, because one of the things about comma-separated value files is that unlike many other file formats that we use in computing, these are human-readable, which means that a human can actually look at it, for example in a text editor, can look at what's actually inside the file and make some sense of it just by eyeballing it. So I'm going to open this one with TextEdit. We'll see what's different. Okay. You can see we've now got an extra column called column K, and we've got an extra value at the end of each line of values. Okay, so the values in each line are separated by commas. That space there doesn't separate a value because it's a space, not a comma. So we've got a complete value here, Tibble's keep, a little fragment of text, and then we get a line break at the end which tells Excel or R or any other program that can read CSVs that that's the end of the line and it's got to move on to the new line and start reading values as values into the columns again. If we look at that, it's this text which is broken up is about Tibbles and data frames. It says Tibbles keep the features of data frames that have stood the test of time and drop the features that used to be convenient but are now frustrating. Let's open that in Excel and see what it does with it. Yeah, and as we can see, it's just added another column to the spreadsheet. Brilliant. And this column has text in it, and Excel has aligned text to the left, whereas it aligns numbers to the right, because that's how we usually want to read them. There's no alignment in the CSV file itself. This is just how this is just what Excel does after interpreting the CSV file as a spreadsheet. Let's look at a slightly more problematic example, though. I'm going to open this one with a TextEdit. Oh, sorry, with TextEdit, and we'll see what's in there. Okay. Now the difference is that we've got the same column K, which is little fragments of a sentence of text, but here something has happened to the middle fragment. We've got a comma in that bit of text. Of time, comma, and drop. Now, what is going to happen when Excel tries to interpret this? Let's have a look. Okay. It thinks that of time is one value, and drop is another value, and it's only after that that it gets to the line break and starts again on the next line. So we've got, incongruously, we've got an extra column here with no column name and with only one value in it, which is the words and drop. Okay, now this clearly makes no sense, but Excel has gone ahead and opened it anyway. R would actually refuse to do that. It would complain that one row or one line had more values in it than the others. So it's not rectangular and it can't open it. Okay, how can we deal with this problem? Because this is often going to happen if we've got text in a CSV. There will be commas in there because that's how people write in English. So let's have a look at a CSV file which has tried to solve that problem, or rather whose creator has tried to solve that problem. Now you see what's happened here is that while the numbers are just as they were before, all of the bits of text are now surrounded by quotation marks. So everything between a pair of quotation marks is a single value. Okay, so we have column A, column B, column C, etc., that first row of column names. But then after this, you can see we've got quotation mark, of time, comma, and drop, quotation mark. Let's see what happens. Okay, and now we can see that of time and drop is a single value. Okay, Excel has recognized that the comma there does not separate two values because they were wrapped up in quotation marks. So the comma is part of the text. It is not a comma separating two values. So now our data is rectangular again. We have column K, which has these fragments of text, and one of those fragments of text happens to have a comma in it. All working perfectly now, because what we've done is, or the person who created this file did, was they have quoted all of the text values. And anything that's between two quotation marks is just treated as text and not as something that might interfere with the interpretation of the file. So this would open fine in R, just like it does in Excel. Let's look at one last problem though. I'm going to open this with text edit. Now what we've got here, we have that value as before. We've got these as before, of data frames that have stood the test of time and drop, and these are all surrounded by quotation marks. But here we have not only a comma inside one of these text values, we have also a pair of quotation marks, because here, for some reason, the word time has been put into quotation marks. Oh dear. What is Excel going to make of that when it tries to open it? Oh no, another mess, okay? It thinks that of time with a quotation mark for some reason in it is a value, and drop with a quotation mark in it is a value. It didn't know what to do. What it did basically was it got to, I'll just open that again with text edit. Here we are. Okay, it's saying, okay, everything in here is a piece of text which is quoted in quotation marks. Everything in here is a piece of text, so that's one value, it goes in one column. Next one, okay, everything between these two quotation marks is a value. And oh, hang on a minute, what's this? Is that inside quotation marks or is it not? And then we seem to be outside quotation marks because there's an opening one here and an opening one here. And then we've got a comma. Oh, so we must want a new value now. And then, so here's the new value, and it's not in quotation marks. And then right at the end, we have one quotation mark by itself. Where's the beginning of that one? Inside this value, there's no beginning quotation mark. So this, well, what do we do? Excel doesn't know what to do. So it tried to do something which didn't make any sense. R, again, would refuse to open this. It would say that that one of the rows has more values than the other rows. It's not rectangular, can't deal with it. No. So this is just an example of some of the problems that come with CSV files. They're nice because they are simple, very, very simple file structure there. it's human readable. A human can open it with a text editor or with another, with something else. Look at look what's actually inside that file and understand it, or at least understand what kind of thing is there. They're also very easy to interchange between different programs because they're so simple. You can open it in Excel, you can open it in Numbers, you can open it in Calc, you can open it in R, you can open it in SPSS, you can open it in Stata, etc., etc. Okay, so they're fantastic, but because they are so simple, there are all sorts of problems with them because there's not very much information that you can put into a CSV file to tell other people's computer programs how to interpret that file. Now, this is in contrast with, for example, the native file format of Excel. If I open this in Excel, again, so this is the one which doesn't have any problems, okay? And if I'm going to save this, you might notice there it's been complaining that it hasn't been saved as in an Excel file format. So some features might be lost if we save it. What it means is things like formatting or information about how to break up the cells, etc. It might not survive if we save it in a CSV format again because it doesn't have all that. It doesn't have anywhere to put all that extra information. So it wants us to save it in an Excel file format. So let's do that. Now I'm going to separate it not as comma separated. Sorry, save it not as comma separated values, but as an Excel workbook. Okay, let's save that. Okay, and now close it. Okay, there we have it. Example 4 XLS. And now if we open that in Excel, obviously it's going to be fine. Because Excel likes these, it knows how to read them because it writes them itself. Let's open it in text edit and see what we get. Oh, we're not giving us text edit as an option. I'm going to have to go, where are we? Text edit, there we go. Oh, look at that, right? This is not human readable. Excel loves these files because it knows exactly how to interpret them. It's got lots of information there about how to make the file look like this. It's telling it which font to use there. I can see it's telling it to use the font Calibri. There's no information about fonts in a CSV file, for example. But no, humans can't read this. Okay? And it can be difficult to open in other programs. It's possible to open Excel sheets in R using a particular library called ReadXL. But this is not an ideal format for exchanging information between people who use different programs to open it. R has its own native format, RDS, which again, it will save lots of extra information, lots of metadata to tell R how to open this file and how to interpret it. But RDS files are not human readable, and they are not, as far as I know, they're not readable by any other program apart from R. So those are the problems with them. So we're going to carry on working with CSV now, but we'll be using some functions from the particular tidyverse library called readr, which will help to avoid the sort of problems that we were looking at today.